Hey guys, welcome back. Another day with Wilhelmina Hicks, that math teacher. I'm going to try something new here. Let's do an SAT tip of the day. I'm going to do these 3 to 5 times out of the week. So you guys that are getting ready for the SATs, let's give this one a try today. We're going to solve a radical equation. We're going to solve a radical equation. Okay, so what we have here is a radical equation, of course. And the first thing you want to do is isolate the radical. So I need this radical part by itself. So what I'm going to do is subtract 4 from both sides. I'm going to subtract 4 from both sides. So that gives me radical 2x plus 6 equals the plus 4 and the minus 4 zeros out, equals x minus 1. So the trick into solving a radical is to square both sides. Squaring a radical, so if you had the square root of 4 and you were to square that, this square and this radical cancel each other out, so to speak. So what we're going to do, we're going to square both sides. We're going to square both sides. So let me rewrite this for you here. So we got the radical of 2x plus 6 equals x minus 1. All right, so we're going to square both sides. Now, when I square the left-hand side, like I said, the square and the radical cancel each other out. So that gives you 2x plus 6. Now, on the right-hand side, usually most students will do this. X squared plus 1. No, no, no. No, no, no. Illegal. Because what you have here, x minus 1 squared, is really x minus 1 times x minus 1. Okay, it's 6. So I have to do the FOIL or distributive property, whichever way you learn. Yes, you're going to have the FOIL. And these are the same binomials. So to make it easy for you, we'll just do the FOIL first. And you guys that know about perfect square trinomials know that you're going to have minus x plus 1, which gives you x squared minus 2x plus 1. And this is a perfect square trinomial. That's a little bit of extra information there, but a perfect square trinomial, how do we know it's a perfect square trinomial? Because you multiplied the same two binomials. All right, so x minus 1 parentheses squared is x squared minus 2x plus 1. And if you notice, minus 1x here, negative 1 times x, negative x, you double it. Perfect square trinomial. Okay, so now, because of this 2 here, this exponent of 2, I know that I'm dealing with a quadratic equation. My highest power is this 2. I'm dealing with a quadratic equation. So with a quadratic equation, you need to move all your terms to one side. All right, I'm going to move all my terms to the right. Does it matter? Not really, but I usually go where the leading coefficient is positive. The leading coefficient here is 1, which is positive. So I'm going to move all my terms to the right. So that means I'm going to subtract 2x from both sides. And I'm going to subtract 6 from both sides. Well, on the left, everything zeroes out. Everything on the left zeroes out. That gives me my 0. Is it important that I write down that 0? Yes. Equals x squared minus 4x minus 5. Okay? So now you need to know how to factor. Could you use a quadratic equation? Yes. But I think I can factor this pretty easily. There's no GCF, so I need two numbers that add up to -4 and multiply to -5. So add up to -4. -5 plus 1 would add up to -4. And -1 times 1 would multiply. All right. Now there's something called the zero property rule that makes it legal to do this next step. We're going to take each binomial, x minus 5, set it equal to 0, and solve. So one solution is 5, and the other solution is -1. Now, with these radical equations, you have to be careful. You have to be careful with these radical equations. You need to make sure your solutions work. Make sure your solutions work. So I'm going back up to the original equation. So I'm going to type in the original equation. And I'm going to plug in the solutions to make sure that they work. So when you're dealing with a radical equation, you want to plug your solutions in. On the SAT, you will have a choice that says -1 and 5. Don't fall for that trap. So let's plug in -1. And this is the section. This problem came from the no calculator section. So we're going to do all this by hand. All right, the right hand side is easy, so it's 2. Over here, I got the square root of 4 plus 4. So that's going to be 2 plus 4. And we can see that even though these are called extraneous solutions, because we are squaring, sometimes you end up with a solution that is not really a solution. So -1 is not a real solution. It's not a solution. It's an extraneous solution. So -1 would not work. No. Now let's plug in 5. And for time's sakes, 5 does work. So your solution for this radical equation